This video is going to cover systems, so A.4e, A.5d, systems of equations, the three different methods that we learned: graphing, substitution, and elimination, and then solving a system of inequalities by graphing it. Okay, so here are the notes pages from these three sections. You should already have these, but here's for you to go back and look. So we solve by graphing, we're looking for where they cross. Alright, if it's infinite solutions, there'd be the same line. No solution would be parallel lines. Solving by substitution, solving by elimination. So you have the steps there for you to copy down in your notes if you've forgotten. We are just going to work through an example and solve this system, negative 2x plus 3 plus y equals 3 and negative x plus y equals 4, three different ways. So when I solve by graphing, the first thing that I need to do is get y by itself in each equation. So in this one, I have to add 2x to both sides, and I get y equals 2x plus 3. And then in the second equation, I need to add x to both sides, and I have y equals x plus 4. Now that I have them both solved for y, I'm going to graph them. You can graph them by hand if you choose, but I'm going to use the calculator. So I went to the menu and went to graph and typed in both of these equations. I'm going to draw it, and then I can see both lines, and I want to know where they cross each other. So I'm going to press G solve, and I want this option right here, intersect. So if I look at where they cross, it tells me that they cross at 1, 5. So my solution would be 1, 5. Okay, then we're going to take this same problem and solve it by substitution. When I'm doing substitution, I need one equation solved for one variable. So what I'm going to do, I already know that the first equation, if I solve it for y, I get 2x plus 3. So I'm going to take that and I'm going to plug it in for y in the second equation. So now I have negative x plus 2x plus 3 equals 4. Now I only have one variable, so I can solve for x. So if I combine my like terms, negative x plus 2x would give me x plus 3 equals 4. Subtract 3 from both sides. So x equals 1. Now I'm going to take that 1 and plug it back into one of my equations to get what y is equal to. So I'm just going to use this at the top. Y equals 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. So my solution, alright, again as an ordered pair, is 1, 5. Alright, so same system, different method, same solution. Our last option is going to be elimination. And remember, for elimination, we are looking for opposites. So I need one variable to have the same number as their coefficient, but with opposite signs. So since the y's already have the same number, I'm going to make them opposite signs. So there's a number of different ways to do this. What I'm going to do is multiply everything in the first equation by negative 1. So when I do that, now my new equation, negative 2 times negative 1 would be 2x, y times negative 1 would be negative y, and 3 times negative 1 would be negative 3. Now, so I'm done with this one. Now I'm going to take these two equations that I have and I'm going to add them together. So negative x plus 2x would just be x. Y plus negative y would be 0y. So my y's are now canceled out. And then 4 plus negative 3 would be 1. So I have x equals 1. And again, I'm going to take that and plug it back in to one of my originals. So if I have negative 2 times 1 plus y equals 3, that means negative 2 plus y equals 3. And if I add 2 to both sides, I get y equals 5, which makes sense because I should get the same answer every time, no matter what method I use. So those are the three methods for solving systems of equations. Then we're going to look at solving systems of inequalities. So what we're going to do is graph both inequalities. Alright, so the first inequality, y is greater than x plus 1. So I'm going to put my y-intercept at 1, and then if it's just x, that means the slope is 1. So I would go up 1 over 1, up 1 over 1, up 1 over 1. Alright, because this is just greater than and not greater than or equal to, I'm going to have a dotted line. Alright, to show that the line is not included in my solution. Then I'm going to graph the second equation. So y is greater than or equal to negative x plus 1. So I still have a y-intercept at positive 1, but this time my slope is negative 1. So down 1, right 1, down 1, right 1, down 1, right 1. Because of the or equal to part, this is going to be a solid line. Alright. Then I need to do my shading. So if I look at y is greater than x plus 1, I need to shade greater than, which would mean above the line. Alright, so above the blue line. And then the red line, y is greater than or equal to, so again that would be above the line. And then my solution is anywhere that the two shadings overlap. So this purple region would be the solution to that system of inequalities.